Hello and welcome to Banks and Markets. In this video, I'm talking about the Treynor measure of portfolio performance evaluation. So, in this Treynor's composite performance measurement technique, I need the return from the stock or the portfolio and the risk-free rate so that I can find out the excess return, which will be my numerator, and the risk, which is represented by the beta. Okay, because as I said, the Treynor takes the assumption of CAPM. Now, basically, I need to apply this formula to get the Treynor ratio. So basically what I therefore need to do is find out the return of the portfolio. Now in this case I'm talking about the Treynor for the market, so 7%, take away the risk-free rate, which is 4%, and therefore I can lock it, and it is divided by the beta, which is 1, because this is the beta of the market. So if I scroll it down now, I can get this. So I've just done it up until X, Y, Z and the market. So now higher the better. So that basically means Treynor of portfolio manager Z is the highest. Okay, so Z has performed in terms of superior risk adjusted return. Manager Z is performing the best. Now this is something we can plot in the form of a graph and can see. So when I plotted it here in the graph, what I can see is this is the 4%. So from this 4% I can sketch the line, and that line will go via the market, which is 7% return, 1 as the beta. So the returns above this security market line are definitely giving superior returns, and those below are not. So that's something we can note from this example. So the results basically indicate that investment manager here, who is this? Let me put the labels, and let me change this to the names so I can find. I don't need this, but I want the name, series name, value from cells. So market XYZ, and if I close it, okay, yeah. So you can see that the portfolio X not only ranked the lowest of the 3 managers, but did not perform as well as the aggregate market on a risk adjusted basis. In contrast, the Y and Z beat the market portfolio, and manager Z by a small margin, but has performed better than manager Y. Both of their portfolios are above the SML line. Okay, so that's the simple example. What I would like to add on this example now is the case of P and Q. Now what I say here is, in the case of P, the average annual rate of return is 3.5%. So basically, as soon as I put 3.5% take away the risk-free rate, you know that I'm going to get a negative excess return. Okay, a negative excess return, because 3.5 is smaller than 4%. So therefore, I have received this negative excess return. Now, if this is the case, which means a portfolio with a negative excess return, if this is the case, what is happening here? So, very poor return performance or very good performance with very low risk may yield negative t values. Okay, so there could be two ways to get this negative Treynor. One, when the numerator excess return is negative. Another, when the risk represented by beta is negative. Okay, obviously here when the excess return is negative, the performance of portfolio manager P is poor. There's no doubt about it. Okay, but in the case of Q, the average return is higher than the risk-free rate, which is 4%, which means the numerator, i.e. the excess return, is positive, but the beta is negative. So what will happen? Again, the Treynor for Q will be negative. Okay, so let's see here what has happened. So that's 5% minus 4% will give you the 5% minus 4% will give you positive 1. Okay, but now what you also need to do is divide it by the beta, which is 0.2. Here what we also additionally needed to do is divide it by the beta 0.5. Okay, so now Treynor for Q is negative, but this negative is caused by the beta being negative. So in this case we cannot say as we said for portfolio P, we quickly said in the case of portfolio P the performance is poor, but in the case of portfolio Q we need to check and ensure how the performance is. So first thing what we can do is, again, we can plot this in the XY scatter diagram, and now as you can see, after plotting this, I can, similar to before, draw this. So that's 4% takes me to 7, which is here. So remember what we said is above this line they are giving good returns. What is this? So let me put the labels again. Add data labels. Now I'm going to format this, and therefore I don't want the y values, but what happened? So let me do it again. Alright, let me close it. What I want is add data labels, and then I want the names. Format data labels. I don't want the y values. Oh, sorry about this. Now I understand my mistake. Add data labels, and then format data labels, value from cells, and these are the values. Okay, and now if I go should be able to remove this as well. Yeah. Okay, so now you see portfolio Q is this one. This is above the SML line. So this means this is not doing poor. This is giving superior risk adjusted return actually. And if you want to prove this, what you can do is see here, in case of portfolio Q, this is the Treynor. So if you just see the Treynor, then you will say portfolio Q is not doing good. But check this by using CAPM approach. Okay, so you know in a CAPM formula, you've got the risk-free rate, which is 4%, plus you've got the beta, which is 0.2 times, you got your market return, which is 5%. Take away your risk-free rate. Okay, so what do you get here? You get 4%. So this is what you are getting, 3.80. So CAPM, the method CAPM is saying to you that you need 3.80% return. But in reality, your portfolio Q is giving 5%. So compared to the model given, the theoretical given return is only 3.8, but your portfolio is making 5%. Therefore, you're doing your superior risk adjusted return is in fact attractive. Okay, so this is just to say that if you see negative Treynor, you cannot quickly conclude that the portfolio has performed weak or bad or poor. Okay, you need to see whether the negative Treynor is a consequence of excess negative return or the negative beta. And if it is negative beta, then something like this is what you can do to actually evaluate the performance based on Treynor ratio. Okay, so thank you very much for listening me, and in my next video I'm going to talk about the Sharpe ratio.